Okay, in this problem here, it's a two-part problem. The first thing is they want us to convert between milligrams, and let's get that to this, milligrams to kilograms. And they give one more thing here, and they say that even though they give us the mass of one pill is this number of milligrams, they want to know how many there are for 100 pills. So one of the first things we're going to do is we're going to have to convert the mass of one pill and multiply that by 100 pills and then convert from milligrams to kilograms. So let's go over to our work page right here. And as we always say with this, it's incredibly important to memorize the exponents for each of these prefixes and symbols. So you need to know these because it's going to allow us to do our conversions a lot more quickly than any way that you're shown, particularly in ALEKS, the way they show you how to solve these. So first things first, we're going to start off and we're going to go, well, we have 100 pills, right? So we're going to write 100 pills in our table O solving or death or factor label method, whatever you want to put that. And we know that there is, for each individual pill, is 214 milligrams, right? So we're going to go for every one pill, probably should use the real pen, one pill is 214 milligrams, right? So essentially all we're doing is we're going to multiply the 214 by 100. And if you've done this sort of thing before, whenever you're multiplying by something that has zeros, you just add those zeros on the end. So that's going to be 214,000 milligrams. So now we've simplified our problem to just want to go between milligrams and kilograms. And they want you to do it as a decimal, not using exponents or anything. But I'm going to remind you of how we deal with prefixes. As long as we're going between two of the same prefixes in a problem, we can use this really nifty exponent way of doing it. So I'm going to write my number here, 2,100, and by that I mean 21,400 milligrams. And I'm going to try and convert that to how many kilograms, right? So what we're going to do is we're just going to go over here and we're going to look up what our kilo is. Now, when I say look up, we're already going to know this, but if we take a look at kilo is 10 to the third, right? And if we take a look at milligram is 10 to the negative 3, right? So what we're going to do is we're going to, on top of each of these, we're going to write what the exponent is. So we're going to write on top of this 10 to the negative 3. And on top of this, we're going to write 10 to the third. And here's the really cool trick. Whenever you're going from one prefix to another, you can just subtract the two of them, and that'll give you the exponent in your new prefix. So since negative 3 subtract 3 is negative 6, we know that our new exponent is going to be times 10 to the negative 6 kilograms. And then all we have to do is put our number in front of it, 21400. Now this right here, this is a perfectly legitimate answer, except for a couple things. One, if we were to leave it with exponents, we'd want to shuffle the decimal place all the way over so there's only one number to the left of the decimal. But they don't even want that. They want to do it so there is no exponent whatsoever. So we got to get rid of this 10 to the negative 6. Now, there is a rule that we follow, and it's super, super corny. Whenever we're moving our exponents around, it's this: lefty largy, righty reducey. I know this is so dumb, but what that means is this: if you move your decimal to the left, you're going to largy the exponent. Another way of saying that is if you make the exponent bigger, you're going to move your decimal to the left. If you move the decimal to the right, you're going to reduce or lower your exponent. Now in this case right here, we need to get rid of this 10 to the negative 6, right? So we need to get that to 10 to the 0, which is the same as 1, which gets rid of that exponent. So what do? We need to take this 10 to the negative 6 and make it, oops, I almost did the classic error. 10 to the negative 6, we don't want to reduce it farther because that would go to the negative 7, negative 8, negative 9. We actually want to make it larger, right? We want to make it go to 10 to the 0. So we're going to do lefty largy, which means we have to move our decimal to the left. So let's take a look at our number here, and we're going to slide it over 6 spaces to the left, because we want to get from -6 right here to 0. So we're going to go 1, 2, 3, 4, 5, 6. Our decimal is going to be here, and we're going to add a 0 in front of it. And where does that leave us as our final answer? It's going to be 0.0214 kilograms. Again, the number one thing that I would remind you of this is memorize what the exponents are and what the prefixes are that match up to it. And then anytime you're converting from one prefix to another, you can use the exponents of the first, subtract the exponents of the second, and that'll give you the overall exponent differential between the two prefixes. Hopefully this has been helpful.